and the learning should be done at the right time. That means at that time. After after finishing that thing, you are learning means that time has gone. Okay, that means you are okay. Is something happen, guys? Is this is live stream? I can't see it. It says live stream. Can you see me, guys? What has happened to this? It is being live stream. Okay, now it is live stream. Yeah? Sure. Is this sure? Okay. YouTube live. Okay. I believe that this is live streamed also, right? Then we'll move to our presentation. I think you can see the presentation as well. Right. Okay, guys, I'm going to explain you about the tensors. Now, tensors means, guys, in the mathematics, we will be learning something called the tensors. The physics also we will be learning something called tensors. The same thing we will be learning in the machine learning as well, but the way of defining that one is different. The tensors means, guys, now in physics you have learned about vectors. Okay, vectors, but in the A level you have got only a brief idea. That means the vectors and the scalars. You have learned it as vector means it is a quantity which has both magnitude and direction, and the scalar is a quantity which has only the magnitude. But it is just a basic definition. But the actual definition you will be learning in your higher studies. That means if you are doing undergraduate level mathematics, you will be learning what is that one. That means this vector belongs to a group or the set called tensors. Okay. There it will be explaining what is the mathematical idea behind the vectors. Okay. So, but the machine learning definition is somewhat different. Okay, we will be explaining only that machine learning definition. So, guys, tensor actually it is a data structure. You have learned data structures in your second years. Data structures means basically it is a way of storing data. That's it. The data structure means it is a way of storing data. Now we have learned a lot of ways of storing data. Array list, linked list. Like that way, we have learned a lot of ways of storing data. Okay. Tensor is also a way of storing data. That is the first thing you have to understand. Tensor is nothing, is a data structure. That is a data structure. Tensor is basic data structure in scikit-learn and TensorFlow libraries. I told scikit-learn is the heart of the machine learning, because when we are implementing something in machine learning, we will be using this scikit-learn library. That is the heart of the machine learning domain. And the TensorFlow, okay, TensorFlow and the PyTorch, both are using. TensorFlow is a product of the Google, and the PyTorch is a product of the Facebook. Normally, TensorFlow is the most dominating library in the deep learning domain. Okay. Now, tensors are the basic data structures of that scikit-learn library and the TensorFlow library. The TensorFlow name also comes with the name tensors. Right. Then what are we are going to store there? Mainly the numbers. We are storing mainly the numbers. Characters also we are storing, but 90% of the things are numbers. We are storing mainly the numbers as a tens. Now you will be asking, now we are storing something. How do we store? Okay, that is the thing we want to understand. Okay, how do we store these things? Okay, so that we will be classifying these tensors. These tensors are classified like 0D tensor. 0D means dimension. 0D means zero dimensions. Zero dimension tensors. We will call those zero dimension tensors as scalars. Okay. We'll see why it is zero dimension scalar, zero dimension tensor becomes a scalar. Okay. See guys, if single number is stored like 2 or 3, those are called 0D tensor or a scale. That means if you are just storing a number, any number, 1, 2, 3, 4, 100, 200, anything. Okay. That is a scalar. Okay. 0D means no dimension. We'll see a practical implementation for that one, so that you can use either a Jupyter notebook or you can use anything, Google Colab or Jupyter notebook. There, you can, I will put it to the, here guys, you can say now, import numpy as NP. Okay. First of all, you have to import the library. Okay. Then this store it in a variable. Okay, a equals np dot array. Okay, as an array you can store. Then after that, you have to check what is the dimension value. This means number of dimensions. Now here, since it is a scalar, now this is a 2, it is a scalar. Scalar dimension will come as 0. Okay, right. What is the thing? First of all, you want to import libraries, because now we are dealing with arrays. The handling arrays is done by the NumPy library. Okay, that's why we are importing this import NumPy as NP. So guys, if you are struggling with this one, I will give a one. Sorry, skip this one and come. It will go to the Google Colab and we'll get this one. Google Colab. Google Colab. Right, take a new notebook. Now, how about your implementation? First implementation, have you done? Have you, if you have done, you better upload it to the GitHub, okay, and maintain it properly. And these small things also, you upload it to the what we call GitHub. Now, first import NumPy. Just import NumPy as NP. Okay, shift enter. Now, then what do you want to do? Now I have imported NumPy. Then now I want to have a what we call, okay. What I'm doing, I will be taking this variable called a, and I will be assigning a scalar value to this one. So in an array, we are storing that one. That's why a equals np dot array. So guys, anything, okay, a or b or anything. NP means the numpy dot array. Any number you can put. Okay. Now you will be getting it as a what we call array. So if you put like a here and enter, you will be getting this one. Now you can see the NDIM of this one. A.NDIM means the number of dimensions of this A. Okay, now you know this A is a scalar. Scalar does not have dimensions. That's why you are getting 0. Okay, even it is a simple thing, guys. After finishing this simple stuff, okay, you put a node called Tensors, okay, and upload it to the GitHub. Then there's a person when your employees seen your profile, oh, this guy is studying these things, okay, they will be monitoring those things as well. Okay, they are not actually now these days companies, they do not want to go through your CVs and the stuff, because when checking your CV, everybody is writing something called leadership, teamwork. Okay, uh, the fast learner, those keywords. Uh, what are the other things? Fast learner, uh, dedicated, hard working, smart working. Okay, anything you can write, but you have to have proofs. Okay, if you're a smart learner, you have to show that you're a smart learner. Okay, now this tenses like stuff, because no many guys, they do not know the depth of this tensor. So if you can showcase, you know these things. Okay, I have done something related to this thing. That will be a plus point for you. Okay, right. Then guys, we'll come back to this one. Okay, you understood that one. Then guys, the next thing, 1D tensor. 1D tensor, one dimension tensor, we'll call it as a vector, guys. Okay. Now, guys, one question. Scalar does not have what, guys? Direction. Why is that? I have now proved mathematically, guys. Scalar does not have what? Direction. How? This is what? 0. A dot NDI. Number of dimension of this scalar is 0. Dimension, by using the dimension, it shows the direction, guys. By using this dimension, it shows the direction. The scalar dimension value is 0, means it does not have what we call direction. It has only a value, the value magnitude. It is just 2 here. Okay, right. Now here, when you consider about a vector, you will understand that it has a direction. Okay, now here another variable, I just took it as ARR. Okay, equals mp.array, and here I have given a list. Remember, guys, if it is a vector, you have to represent it as a list. List means the sequence of numbers which is inside of square brackets. That is a list, guys. Okay, that is a list. What is the list? Simply sequence of numbers. Sequence of numbers inside the square brackets. Okay, guys, we'll see this one. Okay, we'll again go to the Google Colab. We'll put like ARR equals np.array, and I will put like a list here, just 1, 2, 3, 4, and shift enter. I will put ARR, shift enter. You will be getting this list there. Now what do you want to do? You want to see the dimension of this value. Here you can see it is 1. 1 means the dimension is 1. This tensor has a direction. Tensor, okay. This is 1D tensor. It has a direction. But guys, when you consider about the dimension of this vector, okay, now I told this is a vector. Okay, the dimension of this tensor is 1. That means it has a direction. Okay, by that only you can say that it has a direction. Okay, and this vector dimension, now you can tell 2 things. One thing is, what is the vector dimension value? what is the tensor dimension value? This is the tensor dimension value. By taking the tensor value only, tensor dimension only, you have to tell that it has a direction or not. Now it has a direction. Vector dimension means now how many elements are available there. How many elements are available here? 4. So here the vector dimension is 4. Now I will tell you the relationship between this scalar and the vector. Okay, guys. See, guys. Now you have only one number here, isn't it? In scalars, you can just represent anything but just one number. 1, 2, 3, 100,000, 100,000, like that way. But anything, it is just one. But in a vector, you can represent sequence of numbers. That means it is a collection of scalars, isn't it? Is that so, guys? Vector means it is a collection of scalars. Vector means it is a collection of scalars. When it is ordered collection of scalars, guys, okay, it will be becoming the 1D dimension, 1D tensor, because you will be arranging it a particular order. That's why it will be getting a 1D. Okay, we will see what are the examples, why are we using these things. We'll be discussing, but after finishing all of these concepts, we'll be moving to the other parts. Is that clear? 1D tensor. Did you understand? Time to time, tell your things whether you understood these things or not. Right. Now we'll move to the 2D tensors. Okay. 2D tensors. I told a name for 0D tensor. I told a name for that one. It is a scale. 1D tensor, I told a name, that is a vector. 2D tensor, I will tell it as a matrix, guys. Okay, now you will understand the pattern. Yeah, okay. Anything in the data science, it has some patterns. Okay. Anything and everything, those have some kind of patterns. Okay. You are doing a game with these patterns. That is the data science. Right, guys. We'll see now this 2D tensors. Okay, we'll call it as a matrices. Okay, collection of multiple vectors is a matrix. What is called a matrix? Collection of vectors, guys. See this one, guys. To represent matrix, I will put like MAT. MAT equals np.array. Okay, as we are storing it as array. Okay. Now see this one. This is one array, guys. One list. 1, 2, 3, and 4, 5, 6, 7, 8, 9. One list. All of those things, since all of these lists are available, I will be taking it as a 2D array because I want to take the collection. That's why I have put another square bracket to take the square. Okay, we will represent and see this one. Okay, now I'm going to represent the matrix. I will take the name as MAT. MAT equals np.array because I am going to store it as array. Here. Now why? Now there are what we call collection of lists. Okay, and I'm taking all these collections. So I have to store it as a 2D array because I have to take the collection. Therefore, I put like this way. Now see 1, 2, 3. There is one thing. Another list I will take and I will write it as 4, 5, 6. And another list I will be taking and I will be represented as 7, 8, and 9. Okay, guys. Okay. Then see this one. I will put like MAT. Okay. Can you see this one? Now this one list, another list, another list. Okay. Do you believe now you can understand it as a matrix? What is this matrix, guys? This is a list. Okay. One list, below to that, another list, below to that, another list. That means it is a collection of lists. It is a collection of lists. List means what? It's a vector. So this is a collection of vectors. Again, come from the beginning, guys. Vector is a collection of scalars. Matrix is a collection of vectors. So the next thing is a collection of what? Matrix. Again, next thing is a collection of that thing. So the collection pattern is going, guys. So what is the MAT dot NDIM? Number of dimensions. That's why this NDIM. So it has two, guys. Okay, what is this two? Okay, matrix. You know that what are these things we call? This one, and this one. We call those things the horizontal things. We call those things as rows. What are these things? This one, and this one. We call those the vertical things as columns. Now, how these two axes are coming? One is for the row direction. That means you can store in the row way. And you can store in the column way. Okay, now you can feel some kind of idea also. One example also you will be feeling. Okay, we'll come to the example later, but if I tell like that, you can store the things in the row way. You can store the things in a column way. What you feel, what you can visualize. Anything can you visualize if I tell like that? Okay. Good. Table. Yes, table. Another thing, you can store it as a table. Okay. What are we storing like a table? Isn't it a data set? Now, your data set, we are in a data set, you have columns, isn't it? You have what? Rows, isn't it? Right, guys. Good. Huh? Okay, we'll move to the next thing. Right. Okay, 2D tensors we got idea. Now we'll see the n dimensions or the n dimensions. Under the n dimension, first thing is the 3D tensor. 3D tensor, I told it is a collection of what? Matrices. It is a collection of matrices. See, guys, this is the first matrix, isn't it? Now, this is the matrix that we have discussed earlier. Okay, now see, the matrix is like a plane. Behind to that one, another matrix. Even behind to that one, another matrix. Like that, consider there are matrices are arranged like that. Okay, now you know that in a matrix, it has rows and it has columns. Okay, matrix. Now, if you take this side, if you arrange another matrices like this way, it has a depth. That direction also it has axis because you are taking the length of that one as well. Okay, so guys, here the rows are there. Here rows are there. Here columns are there. And you will be taking number of matrices in this direction. How many number of matrices? This is the first one. This is the second one. This is the third one. This is the fourth one. Now, what are the dimensions, guys? Okay, the row number, column number, and the number of matrices. Okay, so guys, you will be getting here 3D. 3D means you will be getting what you will be feeling like. It is like a cuboid. So that is we'll be calling as a 3D tensor. So like now it has three values. One thing is for this depth or the number of matrices, and the other thing is the row number and the column number. That is the 3D tensor. Okay. The next thing we'll consider about the 40. Now, guys, again come to the beginning. Collection of scalars is a vector. Okay. Collection of vectors is a matrix. Collection of matrices is a 3D tensor or cuboid. Okay. Now 4D tensor means what? Collection of cuboids, guys. Now you can say this is the first cuboid, the second cuboid, and the third cuboid. If you can arrange this way, we will call it as a 4D tensor. Okay, 4D tensor. Vector of 3D tensor, or other way you can say it is a vector of 3D tensor. Vector means it is a list, isn't it? Now this is a cuboid list, guys. This is a cuboid list. 3D tensor is a cuboid. So collection of cuboids is a 4D tensor. Now you can understand how the 5D tensor is coming. Now it has only one sequence of cuboids. Okay. Okay, guys. Can you visualize the 5D tensor? How they? This is another set of cuboids. Below to this one, you can put another set of cuboids. Upper to this one, you can put another set of cuboids. Like that, you can put cuboids collections one to other, like that, top to bottom. You can put the cuboids. That is the 5D tensor. How then the 6D tensor? Now this is like in a plane, you have put the cuboids in the first plane. In a wall, just imagine there is a wall. You have put the cuboids. Okay. Then when it is a 6D tensor, there are parallel walls. Okay, behind that one. Those also having cuboids. 60. Like that way, you can increase the pattern. Okay, but in machine learning, you want to know only up to the 5D, because the examples. Now see the 5D tensor, you can see now this is the cuboid list, and below to the cuboid list, another cuboid list. Like that, if you are arranging, it is a 5D tensor. How about the 6D tensor? Collection of them. That means now this is a one plane you will be having the cuboids. Take some parallel planes. So make it like that way. So it is the 6D tensor. Okay, before to go to the rank, axis, and shape, did you guys understand all of these things up to 6D tensor? Understood this thing? Okay. Now here the number of guys are only 10. 10 means with me 9. That means they are normally. Other guys, they will be thinking like this is we can have the things in the YouTube, so we can watch anytime like that. They can do like that way. Okay, that's okay. They have to watch, and they have to somehow they have to learn, because they will be having some work. I know some in the what we call internship, but this is my time. So why now I'm doing 3 sessions. Okay, so the singular medium, because they are in the fuel stations, they will be watching. I have seen some guys, they have sent me the screenshots. They are so much dedicated. Normally, for even in that much frustrated duration, also in the singular medium guys, they are having more than 50 plus count. In the USA team, there are no that amount of guys, but the guys, those are there. They are very much encouraged. That's why I'm waking up at 4:30 a.m. because the US time is the Eastern time. It is 7 p.m. something WhatsApp. I mentioned like if the number of guys are not available, then we can without putting the Zoom class, we can put the YouTube live only. Then the disadvantage for you is now I will be sharing my experiences as well. Those things we can't actually put it to the public. Then you won't get that experience. But I think since I am explaining it in the Sinhala medium classes, you can get those things and do. Because I believe that slit guys, they are not sharing the things like the other guys. I have seen like the Mortua and the other university students, they are sharing the things. But in our, I don't know what is that thing. They're not sharing things. Share the who is benefiting from that. You are the person who is benefited. Okay, not the me or the other one. Because when you share a post in the LinkedIn, okay, the recruiters will see that this person is interested with this one. This person is following this one. The content is heavy. Okay, so that one is good because I got appreciation from one of the companies, the high level recruiter. He told that, "Are you doing not this one? I have conducted a Java class." Okay, that person told that this much that Java I have never seen. So, and I asked from your students because actually they know Java very well. Therefore, are you actually doing this thing free? I told yes. Then what is the benefit you are getting? Oh, I am getting so many benefits. The one thing is when I'm sharing these things, those will be going to the where the LinkedIn, the recruiters will identify about my skills. That is one thing. Yeah, that is the main thing. Is that the only thing you are getting? Is us? Yeah, I told yes. But when you are doing something free, normally other people won't get the value of that. So I told yes, but I do not want to earn money from this one. Like that I told. So like that way, guys, if those things are shared, again, this network failure is coming. I think because of some this power issue is there. Rank, axis, and shape. Number of axes. Learn this concept properly. We will call number of axes and the rank and the number of dimensions. All are the same. Okay? The similar names, synonyms. Number of axes, rank, and the number of dimensions. Okay, what is this one? Okay, if you want to identify number of dimensions, we'll see how do we get the number of dimensions by using the NDIM command. We can get the number of dimensions. What is called the shape? How many items can be stored in one axis? In an axis, in one axis, how many items can be stored? That is called the shape. Normally, shape is represented like this way. Now, this is a matrix, guys. Okay. In matrix, you will be having here. This is the first thing is in a matrix we having a convention. First, you have to represent the row number, then this column number. Now, how many rows are available? 3. Okay. How many columns are available? 3. Okay. This is called the shape. by representing like this way, we will call it as, what is that? It is the shape. Okay, and if this is the matrix, you can see here how many rows are available? 2. How many columns are available? 3. So we will be writing it as 2, 3. Okay, it is called what? The shape. Okay, now see how many dimensions are available. This one matrix, how many dimensions are available? Here, how many elements are there? Check. That is the NDM. Now here 2 and 3, but how many elements are there? Just 2. So NDM is 2. Here how many? That's also 2. Okay, that means the number of dimensions are 2. That's why that's the way we are getting the number of dimensions. Number of dimensions, how do we get the number of dimensions? Just count how many elements available in the shape. Just count how many elements available in the shape. That is called number of dimensions. How many elements available in the shape. Okay, then another thing which is called the size. Size means you have to multiply the available elements in the shape. Size means you are multiplying how many available, what are the elements available in the shape. Now here 3 and 3. So you have to multiply. 3 into 3 is 9. Okay. And what is this one? 2 into 3 is 6. Okay. That is called the size. Size means each how many components all together. Okay. Now here there are 3 here altogether 9. Here 6. That is where, how do you get it? We are 2 into 3. Like that way we are taking. Okay. If it is a cuboid, then also another dimension is coming. You are multiplying that thing as well. Okay, the size of a tensor is mentioned here. Multiplication of the shape. Okay, now if we consider about a scalar, okay, if it is a scalar, just imagine the number is 2. What is the size? It is just a 1 number. It is just a 1 number, isn't it? Just a 1 number. So the size is 1. Okay, number of dimension is 0. Size is 1. Just a 1 number. If it is even 100 also, it is just a 1 number. Therefore, size of a scalar is just 1. Always it is 1. Size of a vector. Size of a vector. How many elements available in the vector? You have to check how many elements. Now it is 1, 2, 3, 4. The size of the vector is 4. Size of the vector is 4. See this example, 1D tensor. Okay, just now these are the examples. Why are we using tensors? Okay, why are we using tensors for machine learning? Okay, you can understand. So first thing, why are we using these things? To store data. We are using tensors to store data in machine learning. We'll see now this one. We have to check whether a guy is selecting from an interview or not. Okay, so that as the attributes we have taken as CGPA and IQ, also have taken the district. Why this district is taken? The reason is now if the guy is in Colombo, okay, he can in this type of duration, he can somehow have the transportation and he can come to the area or do the hybrid thing. But suppose the guy is in Jaffna, he cannot come to the Colombo position at the right time, even in this type of situation. So in that cases, they will be taking district as well. If it is in another country doing like that way, they will be taking the attribute as country as well, and they will be giving a higher priority for their country. Okay, that's right. Okay, so you can't avoid this district or the country. So now think this example here. The CGPA is 3.7, IQ value is 94. District is Colombo. Placement is 1. Now, this is a categorical data, guys. Okay, by having a categorical data, you can't do the processing here. So what we are doing, okay, what we are doing, if it is, you can just take, if it is in your location, the required location, you can put either 1 or 0, anything, okay? That's the way that you have nominated, you can take. Now, I'm telling like, if the person is in Colombo, I will put it as 0. If it is out of Colombo, I will put as 1. Okay. If it the value 0 has some more value. Okay. Now that is just a number. Okay. You can't say that 0 and 1 has some more value there. So not like that. This is the way, the conventions. Okay. The symbols, but we are taking. Okay. Now CGP is 3.7, IQ is 94, district is Colombo. So numerical encoding we have to put. So it is, I will put it as 0. Now the placement is 1. Okay. Now this input values, these are the inputs, the placement is the output. Now these 3 things we can store as a list, isn't it? These 3 things we can put like this way: 3.7, 94, 0. This is a list, guys. That means in your data set, if you are taking a row, you can store that row as a vector. You can store that row as a vector. And the same way, if you consider about this district and what are the district that your applicants are applied. Okay, if you want to do analysis according to the district, you have to consider the district column. Okay, district column also, then you can say if the guy is in Colombo, 0. If it is Gold, 1. If it is Jaffna, 1. If it is Candy, 1. Okay, like that way, you will be getting 1s and 0, and it is also a list. Okay, and guys, now here you have 3 things, isn't it? Now this is a vector, but the dimension of this vector is 3 because this has 3 values. So you can put it like this way. CGP is in this direction, IQ is this direction, district is this direction, like that. Okay. So this is the representation of the vector here. CGPA, IQ, and the district, and you can have a visualization here. Okay. One thing is you can store it as a list. After that, by isolately take the vector values, and you can see the visualization. Did you guys understand about this one-day tensor example? Storing as a list and the storing as a row, storing as a column. How about that one? Hello, guys. Are you there? Hasna is there. Every day she is there. Tunisha is also every day there. Shahan is also there. Now I can remember the names also. Okay. Good. Okay, we'll see. Okay, we'll see. If you can stay alive for 25 days, see. I'm not. What is this called? The boasting. This is not boasting, guys. Okay. I'm really mean this one. Okay. Staying up to 25 days means staying 50 hours. Okay, with implementations. Okay, 50 hours of dedication means it is a massive thing. Even you are doing it for 1 week, 50 hours of dedication means, guys, massive thing. If you are continuously doing, okay, surely you can win the things. Okay, you will understand this thing after finishing this series. Okay, it is not you just feel like What is this 2 hours? 2 hours industrial training means it is a big thing, guys. Okay, because you will know what are the things you are earning. In the academics, you do not know. Academics is short term, guys. So academics normally it is short term, but the industry means it is a long term, because you will feel like, I am getting, I can do this implementation. Okay, not like the earlier. I can do. Okay, and in the GitHub thing also you will understand. The academic we have maintained it like this way. Now I'm not like that day. Now I'm maintaining it properly. Now I'm somewhat okay. Okay, but thank me after finishing this series. Okay, you will if you really got that right. Okay, then we'll see. And remember to after getting this lesson, after getting this thing, do the implementation there. These simple implementations also do, guys. Okay, do, guys, because I am telling those things for your benefit, beneficial. Uh, do those things and upload regular maintenance. It is needed. Right. Then what is this? This just just I have mistakenly put. Okay. Every machine learning table, each row is a 1D tensor. Is that clear? Every machine learning table, each row, because row means what? The attributes. Row means the attributes. Okay, it has some values. Consider about the CGPA, the district, and the IQ values. It has some values. Okay, you can put it as a list. So it is a vector, guys. It is a 1D tensor, but it will be a multi-dimensional vector. You can have multi-dimensional vector means you can have the 3 values, or you can have 4 values, you can have 5 values. If you have 6 attributes, your value is then 6. You have 6 components there. Also, in a machine learning problem, each column can be considered as a 1D tensor. Each column also you can consider, because I told that the district column, ones and zeros are coming. So it is also 1D tensor. 2D tensor example. Okay, carefully, guys. 2D means what? Collections of 1D. Collection of 1D. That means it is a data set, a table, guys. See, now CGPA 3.9, 1 to 3, Colombo 3.799, goal 3.6, 112. Again, if you put a numerical encoding, you can put 0 for Colombo, 1 and 1 for Candy. Okay, other way around. If you like in Colombo, you are putting 1, then it is 1. These are 0, 0. Okay, anyway. Okay, then what is that? This is a data set, and it is a collection of what? Vectors. Collection of vectors means it is a matrix. So this matrix, guys, you can put what? You can store this thing as a matrix. Okay. So 2D tensor, very good example is this type of table. Okay. In machine learning, we are storing these type of tables as 2D tensors. Actually, why are we learning these things? When you are getting error, guys, they will mention, okay, this tensor, the error, the name tensor will be there. Then you will understand what is this, what is this error. The error is related to tensor, the storing mechanism. It has to be stored as float or something like that. The data type should be float. They will be mentioned. Then you can easily recognize what is that error. Okay, guys. Collection of 1D tensors is a 2D tensor. So collection of rows in ML data set, collection of rows. That means it is a data set. You can store a data set as a 2D tensor or a matrix. Okay, 3D tensor example. Okay, I have taken this example of a DSSC career, guys. Ona Danucha Dean and Devin. I have taken. We'll see. This example is a natural language processing, NLP, guys. Okay. Okay. The NLP means like there is a way of going to learn NLP. Okay, first learn the machine learning, then learn the deep learning. After that, you can learn the NLP. Okay, because the NLP, to learn the NLP, you should have the strong knowledge of deep learning and the strong knowledge of machine learning as well. Okay, the NLP engineers are earning very high salaries. Okay, the NLP, what is that actually NLP? A short example for NLP. I will, if I write something this way, go, yes, this. I will put like, who is the president? Who is the president of Sri Lanka? Oh, Ranil Wickremesinghe. Okay, Ranil Wickremesinghe, right? How this now? You know that the Google Google has a lot of websites, but how quickly filter and give this the word the answer, direct answer? How these things are coming? That is the thankful to the natural language processing. That is one example for natural language processing. They can understand. Okay, intelligently they can understand what I am asking. They are giving the answer. Okay, okay. Now in some universities, and you guys also doing like this, I guess. When the online environment, the online examinations are going, they are just copying the question and pasting it in the Google and getting the answer. Okay, the some of the many of 90% of the things, if the Google has the answers, they can filter out. If the Google has the answer, okay. Now, if the examiner has prepared it their own way, then you can't find the things because the Google does not know the things. But if you have put the things in the Google web pages, okay, then it can filter out and give the answer. That is natural language processing. So again, come back to this one. Now we'll see this natural language processing thing. Okay. Okay. Give me 1 minute, guys. 1 minute. Okay. Right. Okay. Then we'll come back to this one. This natural language processing thing. Okay. Now we'll see. This is a 3D example. Now we'll see how this is a 3D example. Now I want to write this thing. Okay. I want to formulate these things. Hi Onara, hi Danch, hi D, hi Dev. I want to make implementation for these things. Okay, what is the process of doing this one? Okay, how do you store these things first? How do you store these things? Hi Onara. No, now what I'm doing, I will be making this type of table. Hi, the word hi, the word Onara, word Danuja, Dean, and the Devni. Now, if the word hi is there here, I will put 1. The rest of the thing 0. The rest of the thing 0. Okay, that means only 1 is coming only for this hi. Now this means, okay, these are zeros. That means only the hi is there. Then the Onara. If you want to take this Onara, okay, just put 1 for Onara and all the others will be 0. The same for Danuja. If you want to take Danuja, 1 for Danuja and all these things 0. Dean also the same way, Devini also the same way. Okay. You can see now this diagonal is consists of 1s. All the others are 0. Okay, now see. Now, hi Onara you want to take. Okay, hi means what? Is that only this one or this whole list? What is it? Hi means this whole list, isn't it? Hi comes, With this one and all the other things should be 0. So you will be getting 1 and 4 zeros of list. And with that one, Onara is also there. Onara is another list. What is that list? 0 and 1, other thing 0. 0, 1, 0, 0, 0. So high Onara means it is a 2D array. Is that clear, guys? High Onara means it is a 2D array. Isn't it? Isn't it? High means this array. Onara means this array. Okay. That means 0, 1, 0, 0, 0. That is Onara. Danuja means what? This array. Dean means this array. And Devmini means this array. Then high Onara means this array and this array. That means 2D array. Okay, you want to take after that high Danuja also. Then what's high is this array. Danuja means this array. Okay, what is that? 2D array. Below to that, another 2D array. That means 2D array means what is that, guys? 2D array. You know that 1D array means it is what? Vector. Okay. 2D array means it is a matrix, isn't it? Now it is a collection of matrices. Collection of matrices. That means what is this? 3D tensor. Okay, we'll see. Okay, if you cannot understand this one, if I go to the next, you will understand. Okay. See, guys. High Onara. High means 1 and 0, 0, 0. High is 1, other things is 0. Onara means Onara value is 1, other thing is 0. So what is this? This is high and this is Onara. So high Onara means this 2D array. High Danuja means this is high and this is Danuja. It is a 2D array. High D like this. High Devmini, it is like this. Okay, if you take all of these things, that means it is what, guys? That is a 3D array. How it comes? This thing is for high Onara. This thing is for high. What is this? High Dean, high Danuja, high Dean, and high Dev. So this is, guys, collection of matrices. Collection of matrices. It is a collection of matrices means it is what? 3D array. Did you get this, guys? Did you understand this? This example, did you understand? Comment, guys, whether you understood it or not. Devmini, she understood this. Yeah. Devmini understood. How about the others? Yes. Tatsara. Okay. Shani, how is that? Hasna, how is that? Did you understand? Okay. Kavisan, good. Okay. Okay, we'll move to the next thing. Okay, how to get the shape of the 3D tensor? Okay, now this is our 3D tensor, this NMP problem. Okay, now what are the things? How many, now how do we take the shape? First consider how many elements are available in the one list. How many? Here 1, 2, 3, 4, 5. There are 5. Okay. In a one row, how many vectors are there? Okay, there are 2. That is the second thing. First, how many elements are available? That is 5. Then how many vectors are available in a row? That is 2. Then how many of them are available? This type of how many arrays? This type of 2D arrays. How many 2D arrays are available? 1, 2, 3, 4. Like high Onara, high Tanuja, high D, and high Devmini. Like that way, how many sentences are available. That is called, that is the next thing. That is 4. 1, 2, 3, 4. First, what you want to take? How many elements in one list? Then, how many vectors are available in that for the first sentences or the a sentence? Per sentence, how many vectors available? 2. That means 2 words per one sentence. Then, how many sentences are available? There are 5 sentences. So 4 sentences. The first is for this 5, then for these 2, then for these 4. 4 to 5. The size is then what's that? 4 into 2 is 8. 8 into 5 is 40. I think you got that one. Okay, we'll see another example for 3D tensor. Okay, that is one example is that NLP problem. Okay. Is size and shape is same? No. Shape is this one. Okay. Size is not the shape. Size is, so shape is this one. This arranging like this way is the shape. Okay. The by multiplying the answer that you are getting is the size. Now the 40 is the size. This is the shape. Right. Then next example for the 3D tensor, you can have a time series data. What is called the time series data? That means for regular intervals, if the data is, if you are taking the data in regular intervals, as an example, share market data, stock prices. That means you are taking the stock price value today, tomorrow, the next day, like day by day you are taking. Something you are recording day by day, something you are recording second by second, or something you are recording minute by minute, something you are recording what we call week by week or year by year, continuously per regular intervals. If you are taking data, we will call in that data set as a time series data set. Okay, time series data. Okay, it has a regular way of taking the data. Time series data. Time series data is the data that is taken at frequent time intervals. Example, data of the sham. Daily basis you are taking. Okay, daily basis you are taking. Up to 365 days. Okay, guys. If this is taken for some number of years, then it is a 3D tensor. We'll see how it comes. Now, in the stock prices, I am recording the highest stock price and the lowest stock price as my attributes. What are my attributes? I will be taking the highest stock price value and the lowest stock price value. Day by day, I'm taking. That means how many days per year? 365. The first day, second day, third day, fourth day, like that, go up to 365. Okay. Now, if you take like this way, what is this one? Only up to this 365 days if you are taking. What is that? It is a data set. And it has what? It has rows and it has columns. That is means this is a 2D tensor. Right. We have already told that 2D tensor is a matrix and normal data set is a what we call, it is a matrix. But if you are taking this type of sets, not only this year, the next year, like that way you are taking it for 10 years. That means what will be you are getting? You will be getting the parallel data sets like this way. This is for the first year and another the same way parallel data set you are getting for the next year. Like that we're getting for up to 10 years. That means you are getting like a cuboid. Cuboid means what? It is a 3D tensor. Okay. If you do like this way also, it is a 3D tensor. That means yeah, it is like Sorry, guys. Right, where I have stopped, I told about this 10 years, but it is not needed for 10 years. If you take like 1 month, if you are taking like 30 days, you are taking. After that, you are now 30 days you will be recording. So the same thing you will be taking for 12 months. That is also 3D tensor. Okay, because you are getting the parallel data sets. Okay, that is another example for 3D tensors. Right. Then 4D tensor example. Okay. The interesting example for the 4D tensor is, guys, the image-based data. Okay, the computer vision domain. Okay, consider this one. Normally, guys, if you consider an image, I will go to the Google and show you the image. Pixel values, I will be pixels. Pixels here. Here is the yeah. Right. Sorry. Sorry for that disturbance. Here, consider this one. Now this is the eye, and here you can see like this way they have draw lines, square shape, and each image is considered like this way. This small square. Okay, it has some small square shape things. Okay, those things are called the pixel value. Pixel value. Okay, pixel of an image. Pixel of an image. Okay, see everything. It will be like taken this way. Now see, the pixel is x and y. That means it has the length and the width. Okay. Any image you can take this type of rectangular based small pixel values. Okay. If you consider about any image, you can take like that type of pixel values. Then now this pixel value is no. If you consider like a black and white image, it has some kind of pixel values. If you now this consider about only the red thing, it has some pixel values available here. Now you want to have colorful image. Colorful means the RGB values. Okay, red, green, and blue. Okay, so that what will happen? You will be getting the red thing like this way. Red thing means it is one matrix, and green means another matrix, and blue means another matrix. That means what's that? This one color pixel value means it is a one matrix, guys. You want to have another color means you want to have another matrix. Then if you want to have RGB means you have to have three matrix. Okay, that means you have to have multiple matrix there. Multiple matrix means, guys, it is what 3D. It is what 3D tensor. See, guys, this 1200 into 800 means the pixel value of a one color value. By multiplying by 3 means it is a RGB. It is a 3D tensor. Okay, 3D tensor. Now the next thing, 3D tensor. Okay. Now if you are having a colorful image means, if you are having colorful one image means it is a 3D tensor. Consider you want to have multiple images. Now images also many images, collection of images. Okay, collection of images means you have to multiply that by the number of images as well. That means it is what 4D tensor. Now this means 3D tensor. But you want to have collection of these things as well. That means what? It is a 4D tensor. Okay. It is what, guys? 4D tensor. I think you guys understood that one. Right. Now we'll see. We'll consider about the 5D tensors. 5D tensors, the best example is the videos, guys. Video means it is, guys, an image which is moving fast. I remember when I was small ages, I asked from my mother, Ma, how is that the TV show, the people are talking in the TV like that way? But my mother told that it has some photographs. These photographs are moving, so you can see it like a video. It is not the real actual concept, but because these days the live streaming is another one, but the real the intuition is that one. Okay, that means video means still images are moving. Okay, so videos are basically frames which are moving fast, collection of frames. Suppose a video of 60 seconds. Just imagine 60 seconds video, just one video of 60 seconds, and 30 FPS. FPS means frame per second. Per second, 30 frames, 30 photographs with a resolution of 480 pixel, 480 pixel value. Okay, the resolution. That means 400 into 720. 480 pixel means 400 into 720. And it is a RGB, color image. Okay, now see, pixel value is 400 into 720, and that you want to multiply the RGB, that means into 3. Okay, this means what? The colorful image. This one is colorful image. Then what? You will be having 30 frames. So you are multiplying it by the 30 as well. Okay. Then per 1 second, sorry, the video is last for 60 seconds. Okay, you are multiplying by 60 seconds also. Then only the video is generated. Okay, now these things. Okay, this is what? Colorful image with frames. Okay, and this one with here. This one is 3D. Okay, and if you multiply by this thing, what will happen? It will be a 4D tensor. If you are having number of videos, this is one video. If you consider one video, it is a 4D tensor. If you are having multiple videos, there are multiple videos, means video collection, then what will happen? You have to multiply with the number of videos as well. Then it is what? It is a 5D tensor. So 5D tensor example is a video. So you can multiply and check these things. Okay, 4 multiplied by 1800, like this. So if you multiply, you will be getting a big value. Okay, to store that big value in a 32-bit. Okay, you have to multiply by again 32. So convert into byte, you will be dividing it by 8. Okay, that was a very large number. To convert it into kilobytes, you will be divided by 1200 for 1024. And convert into megabyte, again you are dividing by 1024. Gigabyte, again divided by 1024. You will be getting an answer approximately 27 gigabyte. That means something like a 4 video. Okay, you will be getting this type of large storage value. In a machine learning, 27 point means big value. So to reduce that one, you will be using video encoding. You have heard something called MKV, MPEG, and MP4. By using those techniques, you can reduce the volume of the video. Okay, then only you are getting a slightly lower value. Okay, you can understand why we are using MP4, because of in order to reduce this large amount. Okay. Okay, I think you guys understood up to that one. Now we'll see this framing of data science problem. Now you guys want to go to the industry. Okay, you want to go to the industry and want to be a first junior data scientist or machine learning engineer you want to become. So the last day I have mentioned about the magic sevens when I when I was implementing our first implementation, you have to go through that Magic 7. Then, guys, they will be giving you a business concept. Okay, according to that, uh, business concept, you want to acquire data, and also you want to build the technical concept. Okay, the you have to understand the business concept. Okay, as an example, suppose the Netflix company. I have taken a user case of the Netflix company. Netflix means it is a movie. We calling as a OTP, the biggest OTP platform. Uh, uh, that means this Disney and the Netflix, YouTube, those live streaming platforms. Those we will call it that name. So if you have recruited in the Netflix as a data scientist, they have understood something like the people are subscribed to Netflix, but some of the guys are leaving. They have removed their subscription. We will be calling this removing the subscription as the churn rate. Okay. Now, if the churn rate is more, that means the company is losing. Okay. Now, any company, if you want to become a data scientist, you want to know the aspects of making profits. That is the commercial aspect, because they are hiring you to make the profits for the company. So you want to know what are the ways of generating the revenue. The one way is by having new customers, but taking new customers is a difficult task. The second thing is the existing customers, and you are uh, asking more from the existing customers. That is also not good thing, because then it will be a huge what we call difficulty for the existing customers. Then the third thing is you can minimize the churn rate. Churn rate means that the available people are leaving from the platform. You can reduce that one. So you can build up the machine learning domain for that one. First of all, you want to understand what is your business domain. Okay. So business domains I have explained here, the business concept and what are the data needed for that one, and the technical concept. Now, as a machine learning engineer, you have to understand some things like this way. Now, if you want to do the analysis of the, now human can analyze something, human can identify some patterns and make decision. If you want to do the same thing automatically by a machine learning thing, okay, that means the human analysis, the identifying patterns, and the making decisions. So the main data is available for that domain is the numerical data, and the technical aspect is you can go with machine learning and you can go with the deep learning. Now, if you want to consider about the business problem like human can listen and the speak, there you can take the data as the text data and the audio data. Here you can go with the NLP, but go with the NLP, you want to know ML and the deep learning, machine learning and the deep learning. And also the human can see and the recognize things. Okay. That means you want to also do the things like this way. You want to understand how the burger, what we call the thieves are coming to an area. This type of the crisis is available. The thieves are coming and they are robbing the things. The whole town, it is like a disaster for the whole town. You want to minimize this thing. You can arrange a CCTV cameras and identify the thieves. Okay, this is a thief. Okay, and you can have a IoT connections with the police station. Okay, identify this is a thief, and it will give a some notification to the police station. Okay, something like that way, or even lock the whole house like that way. Doing something like in that cases, you can take the image or the video as the data, and the computer vision and the deep learning is the next thing. Okay, Right, then the brain signal processing. There you can take the EEG data, okay, and machine learning and the deep learning you can consider there. Okay, the how company generate profits there. Um, I told that you can take the revenue from the uh, existing customers and taking from the new customers and also reducing the churn rate. Now, normally, uh, machine learning experts, they are going for this one because these two things are difficult to manage the things, and you can get churn rate that one. You can manage this one. So you are this business problem, you will be converting into a mathematical model. Okay, how do we do that one? Now you have to define what is that. Now I'm going to minimize the churn rate from 5% to 4.7. You want to well define this one. That is the mathematical concept. Churn rate is reduced from 5% to 4.75. Then okay, then we'll see the type of problem. Okay, now we have understood the first thing is convert your business problem into machine learning problem. How do you do? Make the mathematical concept to that one. Okay, include mathematical concept to that one. Like what is that? Churn rate reduced from 5% to 4.75. Then type of problem. Okay, guys, give me 1 minute. Right. Okay. The type of problem. Okay, you want to understand the end result, guys. How do we understand the problem? Identify the end result. Okay, according to end results only, you want to go with the supervised learning or unsupervised learning. If it is supervised, you have to go with the regression or classification. As an example, now you want to identify who are the people leaving from the platform, or who are the people not leaving from the platform. If it is so, it is a classification. Okay, the people who are leaving from the platform and people who are staying in the platform. If you are going to do like that way, it is a classification. But if you do like this way, you want to identify the maximum the people who are leaving from the platform, the amount of the people who are leaving from the platform, the probability of the people who are leaving from the platform. If it is like that way, it is a regression problem. Okay, like that you have to understand and define like that. Then what do you want to do? If those people are leaving from the platform, now you want to minimize the leaving from the platform. So you can introduce something. What is the thing you can introduce? The dialogue is doing like that. Now the people are unsubscribing the dialogue packages, okay, by having the package, and after that they have used it for 1 month. After that they are not paying, and do like that the dialogue, they do not ask you to leave the platform, or they are not going to at once file your low case. What they are doing, they will retain. You do not want to pay for the previous month. You can just put this amount. They are giving a discount. You can put this amount, and again you can renew the package. Okay, like that. Because the customer is leaving from the platform means it is a big disadvantage. Okay. Therefore, they are not doing like that because they want to somehow keep you in the platform. Okay, so you want to introduce those policies. Okay, then also you can understand the current solution. What are the existing solution? Now, the previous data scientists, they have made something to predict the churn rate. Now, your goal is not to predict the churn rate. Your goal is to minimize the churn rate. But the previous data scientists, if they have done a project, the research related to how, what is the churn rate value. Now, the churn rate value of the month, like that, 5%, 6%, like that. By taking those data sets, by taking those attributes, you can get some opinion. Okay, according to current. Then you want to get the data. What are the needed data for that one? Okay, reduce the churn rate, the watch time. How is the time they have watched now according to this one. Now I will be seeing. Now the six guys are available. The five with me six. The five is remaining there. And earlier it was 16. Okay, what was the difficulty? Now I will be considering. Now the power issues are also available. Okay, the maybe the power issue. Is that the power issue only? The maybe I'm teaching very fast. Okay, they cannot understand. Or the content is very heavy. They cannot understand. Because this is more advanced. Whether it is advanced. Okay, like that, I have to consider this. After that, what is the thing? What is my suggestion? Whether I will be continuing this one like this Zoom class, or whether I'm without considering this one, I will be telecast it through the live stream by a recorded video like that, or without continuing in this session, only the USA guys session is continuing, because that is also English medium. These guys also then they can watch that one. Okay, that means I will be having the time period for me. Okay, what will be the major asset for me? Okay, because we all have to have the commercial aspect. If you do not have the commercial aspect, you can't become a data scientist, guys. Commercial, you have to commercialize your product. Anything what you are doing, you want to commercialize. Okay, so you have to see what is the in which way you will maximize your profits. Okay, even it is a free teaching, then also you want to maximize your profits, your part, your recognition or something like that. You have to consider. Okay, now there, if you consider about the Netflix, you want to consider about the watch time. Guys are watching, considering like they are dealing with the 2 hours or something for a movie. But if it is not a good movie like that, people are disappointed and leaving the platform. And Netflix, they are searching for good movies, and if they do not get the good movies, they think like the Netflix is not good. I will be going for Amazon Prime, And some guys are leaving like this way at the middle of the thing, middle of the movie, they are leaving. Okay, how much more they have left middle of the movie. Clicked on recommendation. Now, in the same time, the recommendations are coming from the Netflix. How many of them have clicked the recommendations? Those are the data you can consider there. Okay, then matrix to measure. Okay, model is successful or not. This model is successful or not. If the accuracy is, how is the accuracy of this model? Then the next thing is now the Netflix, normally it is an online platform. So you want to go with the online for the learning mechanism. That means the production mechanism, or it is a batch learning. So like that way, according to the use case, you can decide that one. So guys, the next day, we will be discussing this thing in the next day, the data gathering. Before to move to the next day, I want to tell this thing for the YouTube viewers. Okay, this is one announcement for the YouTube viewers. This data gathering is a very important thing, because CSV, JSON file, SQL, you know only to get the data from the Kaggle datasets or some available repositories. Okay, but you do not know why these SQL things are coming, the JSON things are coming. Okay, actually the CSV files also, you do not know something like the how to get the data from a link. Okay, I believe like that way. And this API method and the web scraping, you do not know a proper knowledge. So these are much needed in the industry. So if you do not uh, want to dedicate yourself to learn these things, because I am doing my research, I have to do lot of things. Okay, but I'm doing this one. I believe that you can gain something from this one. So uh, honestly, comment that one whether what are your difficulties. Okay, if it is not, I can merge this one with the USA guys thing and release the video. Then I can allocate that time duration for my another work. So with that said, guys, we will wind up the session today. We'll discuss this data gathering that will be in the next day. Okay. Thank you, guys. Yeah, I will send these slides to the group. Okay. Is the content is advanced or difficult to manage? What are your feedbacks? Guys, the content is manageable or difficult? Medium. Mhm. Manageable. If you cannot understand, again, watch the video. That's the best way. Okay. Normally, perhaps now you guys, many of guys are in the third year, because without you do not know anything about the machine learning. So this type of heavy content is a little bit difficult, you guys. But I believe that version like the step-by-step rewinding the things and learn will be effective for you. Do like that way. Okay, and if you have any questions, you can put those things in the group. The group is there for that one. Okay, I'm also time to time check those things, and uh, I will help the things. Okay, right. Thank you very much, guys.